go. Next section, piecewise functions. Look at the little graphic here. We got you want a piece of this, and it's a pi symbol. That's pretty hilarious. A piece of pi. We're talking piecewise function. What is a piecewise function? Let's get right into it here. Here's a piecewise function. So I got an example of one right here. I really like to look at the example, but here's the definition. It's a function that is defined by one or more functions. So what does that mean? So this is a function that passes a vertical line test, but it's made up of two different functions. So you've got a line over here, and then you've got a different line over here. So anytime you have two different functions, two or more, it could be, 3, 4, 5, it could be a ton of different functions. That is a piecewise function. It's kind of like your math teacher. You actually this year have a piecewise math teacher. If you think about it, your math teacher is made up of what? Mr. Bean, Mr. Brust, Mr. Kelly, and Mr. Sullivan, or Mr. Rusty Eleven. If you want to, that's creeping me out. That thing needs to go. How do we get? Oh, get out of here! Oh, I can't get rid of it. Okay, so let's look at this. So the piecewise function, what are we going to do with this thing? Well, we need an equation to represent this. So let's go over this in red. If I look at this line over here, can I write the equation of this line? Well, sure. I got to find the slope, and it looks like it's going what? Up 2 over 3, something like that. And what's this y-intercept? It's right there at -1. So I can say, yeah, that part is the f of x equals what? It goes up 2 over 3, so it's 2/3 x minus 1. So this part over here, and I'm going to try to trace it in red just so we know this is the red function, is something like this. Then what else do we have? Let's do a green function over here. So I know it starts up here at 3. What's its slope? It's going, what? It's rising down 1 over 1, down 1 over 1 every time. So I like that function. So this function over here is -1x, or just negative x. And then where does it start? It starts at plus 3. So again, this green part over here, this green function over here, is that. So how in the world can I write this as one function? Well, what we're going to do is we're going to say, okay, this is one function, so we can't separate them. Let's mash them together. So we're going to use this. We're going to kind of mash them together. So we're going to use this fancy bracket right here. So really, this is my function. My function is this, which is great, except I have to define some intervals here. I can't just say it's always 2/3 x minus 1. How do I know when it stops? Well, this is true for what? When x is what? X has got to be less than 0. So here's at 0, everything negative, everything less than 0 for x. Here's all my x's this way. That's defining this function over here. And it's not including it because it's an open circle, so it doesn't include it. But as soon as it hits 0, what happens? Changes to the green function. So every x positive over here is this green line right here. So what does that mean? Every x that is greater than or equal to, because I had that solid dot up here, so that makes that function over there. So really, this is what a piecewise function looks like. It's the f of x. We're going to break it into two or more other functions, and then we have to define the interval where that function exists. So if we can do that, we are good to go. Let's take a look at some examples. Algebraically is not too bad. If I give you one, so check out this piecewise function. It is made up of 3 separate functions. 1, 2, and 3. So I've got 3 different functions going on. The first one is linear. That looks like a line, mx plus b. Check this out. Here's a quadratic. It's got a square in it. And then this one's a square root. So definitely 3 different functions here. Can you evaluate it algebraically? Sure. F of -4, you just got to come up here and say, where does it fall in? -4 falls in which function? The top, the middle, or the bottom? Well, -4 is when x is less than or equal to -2, so it falls into the top. So it falls into that 2x plus 8 function, the top one, and then you're just going to plug in -4 in there. Plug in -4. What comes out if you plug -4 in for x? 2 times -4 is -8 plus 8, and that is 0. So the f of -4 is actually 0. Pretty cool, huh? How about the next one? If I plug 6 in, where does 6 go? Well, it's not less than 2. It's not sandwiched between -2 and 3, and it's not great. Oh, it is greater than 3. So I'm going to put in the last one. So really, I'm going to say, yeah, it falls in this function. X is 6. So it's going to be 6 plus 3. 6 plus 3 is 9. What's the square root of that? It is 3. So it's all about finding the right function. So I can evaluate that point. Can I do -2? Sure, no problem. -2 is tricky because here it's in both of these. X is less than or equal to -2. This is x is bigger than -2. So it actually falls into that top one, that 2x plus 8 again, because that's where it's equal to. So it's got it bar underneath. The bar underneath means that's where it falls in there. So there's -2. Evaluate that. 2 times 2 is -4. Plus 8 is 4. So got that one. And the last one, can I plug 0 in? Sure thing, plug 0 in. Where's 0? Well, 0 is between -2 and 3, so it's in this middle function, this x squared minus 3. Plug 0 in for x. I like that one. Squaring 0, 0 is easy. It's just 0. Subtract 3, you get minus 3. So when it's algebraic, I'm just plugging in points. You just got to find the right function and evaluate, and you're good to go. So algebraically, not too bad. Oh, try one on your own. Look, here comes Mr. Kelly again. There's that wonderful face again. And he's got his little hippie shirt on there. You want a piece of me? Get a piece? Peace sign? I like that one. That's good. Try these. Pause it real quick. See how this goes for you. I'm going to post the answers. All right, here we go. So we can take a look at these. I posted the answers up here. Hopefully you said the f of 8 is 6, and there's the work to support it. Just make sure you find the right function. The f of 0 goes into the top function, so make sure you got that in there. And then I love this one. This one's great. If you look at 4, 4 is sandwiched between 1 and 5, and look, what is this function? And that function is just 3. It's a constant. It doesn't matter what x is. It's a flat constant of 3. It's always 3. It doesn't matter what x is between 1 and 5. It's always 3. So the f of 4 is 3, just like the f of 3 is 3. The f of 2, pretty cool. Anything between 1 and 5 always produces 3. And then you can plug in these. The last one, f of 5 is 3. Awesome. So that's just plug and chug. Very good. How about graphically? What if we have to look at a graph to evaluate these? So we don't know what the function is. It's made up of these 3 different functions. I can see them. They're all lines in this case. Can I still find the f of 2? Sure, no problem. This is just saying when x is 2, what's y? When x is 2, what is y? Here it is right here. It's -1. How about the f of -3? Go to plug it in. Now be careful because I've got an open dot. It doesn't exist there, but here's the solid dot where it does exist. So that looks like it's about 2.5. So go to the solid dot, and then -1. Oh, it doesn't exist here or here. So in this case, it doesn't exist at all because they're both open dots. This does not exist at all. So there, it's undefined. How about -4? Put in -4. What comes out for the y value? It looks like 2. Excellent. Let's come over here to this other graph. So we got a line. This is that constant, that one that was like 3, but this one's always -2. And then it looks like we've got some sine square root going on over here. So the f of 0 when x is 0, what's y? Boom. It is 2. Fantastic. How about the f of -4? If I put -4 in for x, what comes out? There's a 1. How about the f of -1? Again, open or closed? You got to go to closed. That's where it exists. It exists down here at -2. And then the f of 3 out here at 3, what comes out for y? A +3 comes out. Fantastic. So the graph, just look at the picture, plug them in. Excellent. Alright, this is the hardest part, is when you actually have to graph it. So, can you graph these? We're going to stick with lines here just to get us going on these, but it's not too bad. This case it says it's a line when it's less than 0, it's this line when it's above 0. So what I would do is just graph this line, -2x plus 1. I would go ahead and just graph it. Here's +1 where I start. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and then go backwards, go up 2, back 1. So plot all these points. So this is my line here. So I've got this line. If I want to connect all the dots, that's great. There's my line. Except that what? It only exists when it's less than 0. So what I do is I grab my eraser and I say, it can't be positive. It can't exist above 0. So I'm going to erase that. And can it exist at 0? No, it can't. So I have to be careful. I can't put a closed dot there. I have to put a nice big open dot here. So it doesn't exist at 1. Even though it's a y-intercept, it can't be 1. It can be really, really close, but it can't be x equals 0, so it can't make that 1 there. So then I go to my next line, and maybe I'll go different color here. Do the same thing. Start at the y-intercept of -3. And where do I go from there? I go up 2 over 3 each time. Up 2 over 3. Up 2 over 3. Draw my line. In this case, I don't have to go backwards. I mean, you could go this way if you wanted, but it's always positive. It's always bigger than 0, and it's equal to, so I know it's the solid dot. So there's my piecewise function. I'm good to go. Fantastic. How about the next one? Let's check this one out. This says it's 5. It doesn't matter. It's always 5. It's a constant. So when it's less than, or really, it's just like saying y is 5. Remember, that's that special case where y is always 1, 2, 3, 4, 5. It's this flat line where it always is 5. But the key is I'm limiting it. Where is it limited to? Well, when x is less than or equal to 2. So I have to get rid of anything above 2. Here's 2. So above that is gone. And is it solid or open dot? Well, it's got the bar underneath, so it is open dot. So, I'm sorry, it's closed dot. It's closed dot. Everything less than or equal to 2 goes like that. Fantastic. Then everything greater than 2 is what? Well, it's this line. Again, I would go down. I would just graph it. So it starts at 1, 2, 3, 4, -4. And I'm going up 2 over 1, up 2 over 1, up 2 over 1. So put these dots in here. And draw on my line here. Oop, there it is. But what happens here, it doesn't exist when it's only x is greater than 2. So anything less than 2, I'm gone. And can it be 2? No, it cannot be 2 right here. It has to be an open dot. So where was that open dot? It was right here. So make sure you have that open dot in the right spot. And there is my line. So it's a constant, then it's this line going up. And that's how we graph piecewise functions. That's the whole section. Sometimes piecewise functions can be a little bit frustrating. That's okay. Just keep practicing. It'll come for you eventually if you keep practicing, working at it. Just to kind of keep you on the right track, here's a video clip of a guy who got frustrated with a water cooler, so that may make you feel better. You know, this dude's upset with a water cooler. At least you got piecewise functions to worry about. Good luck on the master check. Peace out.